6.6 is solving quadratics by factoring. So first I want to pose a question to you. Think about this. If I said 7xy is equal to 0, what could x be? And then y? Okay, if you thought about it, you're thinking, if I'm multiplying three numbers together and getting 0, one of those numbers must be 0. The only way I can multiply numbers together and get 0 is if one of them is 0. So in this case, I know 7 is not equal to 0. That means that either x is equal to 0 or y is equal to 0. It could be both, that x and y are equal to 0. But I would say either x is equal to 0 or y is equal to 0 when solving this. Look at the next one. It says, if I say 7 times x minus 4 is equal to 0, what could x be here? And then y. In this case, I would say either 7 or this whole term of x minus 4 must be 0 because either this is 0, which we know it's not, or this term must be 0, in which case it is. And if that's 0, then that would tell me that x is equal to 4. So what we're looking at here is called the zero product property. And what it says is exactly the pieces that it spells out. If I have zeros being multiplied together, the product, I'm going to end up with 0. The only way I can multiply numbers together and get 0 is if one of those numbers is 0. So that is the zero product property. And that's going to allow us to solve quadratic equations by factoring. So I'm going to go to the app Desmos, and I encourage you to do the same thing. Before I go there, let me think about this. What is the equation of the x-axis? If I was going to type in an equation and just come up with the x-axis, it would be the equation y is equal to 0. So I'm going to go to Desmos right now. And I typed into the input bar f of x is equal to x minus 4 times x plus 2. So if you look at this, what we're actually looking at is a quadratic. Even though it's two linear binomials, they're being multiplied together. So if I was to distribute those, I would end up with a quadratic equation. Remember, a quadratic equation, when we graphed a line, a linear equation, it was a line, a constant slope, a y-intercept. When we graph a quadratic, the rate is changing differently from point to point, right? 1 squared is 1, 2 squared is 4, 3 squared is 9. I keep jumping up higher, greater steps, and so I end up with a parabola, which is a U-shaped graph, essentially. So when I do these, I'm going to look for where is this crossing the x-axis? Because remember, the x-axis is the line y equals 0. So when I type that into my Desmos, what I notice is I end up with a parabola that hits the x-axis at -2 and +4. And if I look back, why is it like that? Well, because I took this and multiplied it by this. And if I was setting it equal to 0, which is essentially what happened when I was looking for the intersection of that parabola and the x-axis, then either x minus 4 is equal to 0 or x plus 2 is equal to 0. It could be both as well, remember. So I end up with x is equal to 4 and x is equal to -2, meaning there are two solutions of this system of equations. I was looking for the intersection of the parabola and the line y equals 0, and those were my two intersection points at -2 and 4. So what conclusions can you draw? Why is it like this? What do you notice? Well, we notice that it crosses -2 and 4. And it's like that because those are the two values that will make our parabola be equal to 0, the value be equal to 0. Because remember, if I'm going to multiply two things together and get 0, either this whole thing is 0, this whole thing is 0, or both. So let me explain how we're going to use this for solving. it's really just one extra step. So this one is actually already factored for us, but notice that it's set equal to 0. That means either this is 0 or this is 0. So what I'm going to do is what I refer to as a t-bar. In between each factor, I drop a line down to separate them. I do k plus 1 is equal to 0 and k minus 5 is equal to 0. And then I just solve. So in this case, k is equal to -1 and k is equal to 5. I have two solutions here to my system of equations. The top ones are factored for us. So what you would need to do, I'm going to do an example like number 5 where it's not factored for us. And notice it's not equal to 0 either. The zero product property only works when it's equal to 0. If I say x times y is equal to 16, you have quite a few options here. You could do 2 and 8. You could do 4 and 4. You could do -4 and -4. 16 and 1, I can go on. But that only works if it's 0. This is not necessarily the case that x or y here would be 16. So our zero product property only works when I have everything equal to 0. So I need to get everything on one side of the equation and a 0 on the other. So I'm going to add that 5 on both sides. X squared minus 11x plus 24 is equal to 0. And this is just a quadratic that I know how to factor. So this is what I'm going to factor. Looking for factors of 24 that add to give me 11. What are they? The factors are 8 and 3. Signs are the same. They're both negative. So I get x minus 8 and x minus 3 are equal to 0. Now I'm going to do a t-bar, so I split my factors. And I get that x minus 8 is equal to 0. X minus 3 is equal to 0. So x is equal to 8 and x is equal to 3. And those would be my answers. The key thing here is really just getting the quadratic all by itself. So regardless of what's on the other side, everything needs to be on one side of the equation and there needs to be a 0 on the other. So I'm not going to solve this one for you. You guys can solve it on your own. But I just need to move everything over to the other side, keeping in mind when I move across the equal sign, I need to do the inverse operation. I'm going to move everything at once actually, but keep in mind like terms as well. So this one would be a special case factoring. I would multiply a times c and look for factors of 45 that would subtract to give me 4. Okay, really one extra step on top of, possibly two, on top of what we've already been doing, which is t-barring when you're done and setting both pieces equal to 0 and solving. The other extra step that could possibly exist is getting everything over to one side before you start factoring.